Okay, guys, this is our next section, and it's going to be area and circumference of circles. And this is 8.5. So how do you think the area of a circle is derived? One way to look at it is to think of a circle and pretend if you fold it in half 4 times. Well, you would end up with 16 even regions or wedges, like so in the picture below. So you have all of this right here. And so you would have all of these wedges like that. Okay. And so if you put them all together and arrange them in a row, like so over here, what kind of shape would it form? So I kind of already outlined it in red. What does that look like? That looks like a parallelogram. Okay. So we already did area of a parallelogram. So what would be the area of all these wedges, which is the area of this circle? So let's do base times height. So base times height is area of a parallelogram. Well, what is this base represented as? Okay, it's represented as all these arcs right here. So think of every arc right here, all of these arcs. What is that put together? All of the arcs. Well, that's what we call circumference, but it's only these arcs down here and not these arcs over here, so half of the arcs. So it's kind of like half of circumference times the height, but in this case, what does that green represent in each wedge? The radius. So that's why you see r there. What is the formula for circumference? It's 2 pi r. Okay. Well, what's half of 2? Just 1. And then what's r times r? R squared. And there it is. Area of a circle is pi r squared. So that's one way to look at it. So the conjecture goes like this. The area of a circle is given by the formula A equals pi r squared, where capital A is area and r is the radius. And you guys are real familiar with the radius. The radius goes from the edge of the circle to the center. Okay, and multiple radii, no matter how many are in there, they will all be the same length in the same circle. Okay, so let's just do a couple of examples or a few examples using the formula pi r squared and maybe circumference, okay? And this is what you did do in middle school. So on this one here, we have a 12 here, and whenever it's in the middle, it's going to represent the entire segment there, which is the diameter. So to find the exact area, well, we know that r is going to be 6 because it's always half of the diameter. So area equals pi r squared, and r is 6, which 6 squared is 36. And we're going to leave it in terms of pi, and that's going to represent the exact area, okay? They didn't give us any units, so we'll just put units squared. So that's the exact area when you don't multiply it by pi, okay? Now, the estimate of the area is when you do multiply it by pi. So a lot of you guys used to use just 3.14. But now what I want you to use, and this is on everybody's iPhone calculator or Android calculator, when you turn it sideways, you can see the pi symbol on there, and it's at the bottom in the middle. So all I'm going to do is hit 36 times and then press that pi button and then hit equals. And so the estimate is about 113.097 square units. Okay? So this is the exact area when you leave it in terms of pi, and this is an estimate when you round it. Okay, let's look at the next one. It gave us capital C, which that's going to represent circumference. So if you look at your formula chart, the formula for that is pi times d, or 2 times pi times r. Okay, so it doesn't matter which one you use. So I'm going to use the smaller one. So I have 62.8 equals pi times d. I'm going to divide by pi, and that'll cancel, and that's going to be my diameter. So let's take 62.8 and divide it by pi in the calculator and hit enter. And if we round to the hundredths place, we get about 19.99. Okay, so if we really wanted to round it to only the tenths place, then we would say about 20. Okay, and so if this is 19.99 and I hit divide by 2 in my calculator, I get 9.99, which is about 10. Okay, and so you're asking, well, which one should we put? Okay, well, when we do it this way, I mean, the decimals are fine. If we happen to round that way, it should be okay as well. All right, so now if I want to do the area, I'm going to just use the 10. So I'm going to use a different color. So area, remember, equals pi r squared, which r is 10. And so that's about 100 pi. Okay. And so I have that long number still in my calculator. So when I square it, I get 99.9 pi, which is about 100. And then I'm going to hit times pi. And so I get about 313.84. Okay. All right, let's try one more. Over here, they gave us the area and we need to solve for these measures here. So remember, that's equal to pi r squared. So if the area equals 48 pi and that equals pi r squared, I'm just going to write it again. pi equals pi r squared. Well, if I divide by pi from both sides, look what happens. Those cancel out. So I have 48 equals r squared. And then I'm going to square root to get r by itself. That's how you get rid of the squared. And r is going to equal, I want to leave the exact answer on there. So I'm going to use my factor tree, which I believe 16 goes into 48 3 times. So I'm going to do 16 times 3. And there's a perfect square. And then I'm going to underline that. I don't know why I underlined the 16. So the radius is actually 4 radical 3. That's the exact answer. Let's say we wanted to give the estimate. So I'm going to take 4 and multiply it by the square root of 3. And I get about 6.93. I'm going to move this down a little. Okay, and then the diameter, you know, is double the radius. So 2 times 4 radical 3, that's the exact diameter, which that one I'm going to hit times 2 in my calculator. About 13.86. And then the circumference, remember, is pi times diameter, which in this case, the diameter is 8 radical 3. So the exact answer would be 8 pi radical 3. Okay, that's the exact answer, leaving it in terms of pi and in radical form. So I'm going to take the 13.86 and I'm going to times it by pi in my calculator, and it's about 43.53. Okay. All right, so all right, let's go to the next section. The next section is called 8.6, any way you slice it. So we're going to apparently be taking slices of the circles now. Okay, so parts of a circle. So the first one is called sector of a circle. This is the region in a circle between 2 radii and an arc. So think of a slice of pizza. So there's a sector right there. Go ahead and draw that on your notes. Make sure you draw a sector. So the formula, I'm just going to go ahead and straight give it to you. Here's a visual of it, okay? Whenever you think of trying to find the area of a sector. So you're going to have a fraction of a circle that we need to take. Well, a full circle in degrees is 360. So we need to take X amount of degrees out of 360 and then times it by the area of a circle, and that's going to give us the area of a sector. So the formula is going to look like this. X over 360 times, well, we know area of a circle is pi r squared, and that'll give us our answer. Okay, now x degrees is the angle right there, central angle. We learned that back in chapter 1, which is also the same as the arc measure. So this arc measure right here that's in red is also going to be x degrees because those are always the same. Okay, and you know all the way around the circle, 360. All right, so let's try some examples with that one. So here we have the area of this sector that we need to find the exact area, and then we want to give an estimate. So we're going to use our formula. It's x degrees out of 360 times pi r squared. Okay, so we're working with 60 degrees over 360 times pi 3 squared. So I'm going to reduce this fraction here. You can reduce it in your in your calculator, or you can do it by hand the way I'm doing. Divide by 10, it knocks out the zeros. 6 over 36 is 1 over 6. I'm going to move this out in front, which is 9, and then pi. How do we make that as a fraction? Pretend that's over 1, so it's 9 over 6 pi, and then that gets reduced because 3 goes into both of those. 3 over 2 pi. So the exact area of this shaded region right here, that sector, is 3 over 2 pi. Okay, that's the exact measure, and this is in inches, so you could say square inches. So what is the estimate of that? Well, it's just a matter of putting that in your calculator. 3 divided by 2 is 1.5. So I'm going to put 1.5 times pi equals. So the area of that shaded region, the estimate is about 4.712 square inches. Okay, let's try that again over here. The exact area of the shaded region, the sector that is usually shaded, is what they want you to find. And so this is 90 degrees because that's there. So how many degrees is this right here? That would be 270 degrees, which 270 out of 360 is 3/4. Okay, so that's one way to think of it. So 270 out of 360 is 3/4. So we can actually put 3/4 times pi r squared, which is 2 squared. Okay, so we have 3/4 times 4 times pi. Remember, put that over 1. Look what happens to those 4s. So we basically have 3 over 1, which is 3. So 3 pi. So the exact area is 3 pi square meters. And then it's just a matter of putting it in your calculator to give the estimate. So 3 times pi equals 9.425 meters squared. Okay, and that's how you find the area of a sector. Here's the next definition. Segment of a circle. What is a segment of a circle? It's a region in a circle between a chord and an arc. So I have it shaded right here. Here's the chord, and here's the arc. So how do we find the area of that? That's what's going to give. That's what's going to come up next. So just so you know, that's the segment of a circle. So let's think of a visual. Okay, well, I would probably want to find the area of that entire sector. Okay, so I'm going to highlight that. Let me get my highlighter. I'm going to highlight that in blue. So think of this sector right here. So imagine if I found the area of that whole entire sector, right? So if I found the area of that whole entire sector, well, I don't want this part right here. Well, what shape is that? That shape is a triangle. So you take the area of the sector, you're going to subtract the area of the triangle, and that'll leave us with area of a segment. So what does the formula look like? Well, area of a sector we just did, so there it is. I just wrote it again from the previous page. And then you already know area of a triangle, that's 1/2 base times height. And when you do that, that'll give us the area of a segment. Here's the next definition in annulus. This is going to be the region between 2 concentric circles. So we have 2 circles here. We have circle 1 and we have circle 2. And both of those share that same center right there. And so it's going to be the region between those two. So the shaded part is your annulus. So think of kind of like a donut or a tire. What is the formula for that? Well, it's taking two circles basically and subtracting them. So that's pretty much what it is. So the area of the big circle minus the area of the small circle gives us the area of an annulus. How does that formula look? I just did a big pi r squared to represent the bigger circle, and I did a smaller pi r squared to represent the small circle. And that's area of an annulus. So let's just go into some examples and then we are done. So on this one here, I'm going to find the area of this segment. So remember, I had got my highlighter a second ago, and I highlighted the area of the sector. So I want to find the area of that whole entire sector. And then what I want to do is I want to subtract the area of that triangle right there. I need to get rid of that. So let's write out the formula first. So I'm going to do x over 360, which, what is x? X is going to be 90. So 90 over 360 times pi r squared minus the triangle. So remember, the triangle is 1/2 base times height. What is the base and the height of this triangle? We just talked about that, as the base and the height are always going to be perpendicular. Well, if this is the base, then that means this is the height. What is the height? Well, it's the radius for the circle, so that's going to be 6. So this is 6 and that is 6. So let's go ahead and simplify this. 90 over 360 is 1/4 pi times 36 minus half of 36, which is 18. Half of 6 times 6, and that's 18. All right, let's simplify this. 1/4 of 36 is 9 pi minus 18. And this is in square inches. So this is the exact answer. Okay, I'm going to write a note there that this is my exact area. Okay, and then an estimate would be to just put that in our calculator. Okay, so I'm going to write it up here. This is the exact 9 pi minus 18 square inches. And then we'll put the estimate. So let's go ahead and put that in my calculator. 9 times pi equals about 28.274 minus the 18. That's about 10.274 square inches. So about 10.274 square inches. Okay, so you know how to do the exact answer and the estimate. All right, let's try this one over here. This one's a little bit harder. So I have to find the area of this whole sector. Let me use a different color. I have to find the area of this whole sector that I'm highlighting in red. Okay, I have no angle measure right there. So how can I find that? I need to be able to find this angle. The only other thing you know is that this is 10 feet. Okay, so you need to think outside the box. Well, what if I draw in an altitude of the triangle right there? Well, if I draw this, remember this is an isosceles triangle, so then up here is going to be 8 and here is going to be 8 because that whole thing is 16. So I can use trig because I now have right triangles to find this angle right here. Well, let's find the height because remember I'm going to have to find the area of this triangle and subtract it. Okay, so remember our formula is going to be x over 360 times pi r squared minus the triangle. Okay, so I wrote my whole formula out. So, see, this right here, I can use Pythagorean theorem. 10 squared minus 8 squared equals b squared. Then I'm going to square root that to get b by itself. And that's going to be this height right here. Okay, so I'm solving for that height. So I'm going to use my calculator. 100 minus 64. Oh, that leaves me with 36. I know the square root of that is 6. So this height right here is 6. All right, so then this is 6, that's 8, and that's 10. And so how am I going to find the area, the angle there? I'm going to have to use trig. Let me get a different color so I can do that. So this angle right here is going to be, I'll just use the 8 and the 10. This is opposite over hypotenuse. So I'm going to do sine of x degrees equals opposite over hypotenuse. So you remember how to solve for an angle? We're going to put 8 divided by 10 and then hit the inverse sine. So that's about 53.13 degrees. So x is about 53.13 degrees. Okay. Now remember, this angle is going to be identical because remember, this is symmetrical because that's an isosceles triangle. So I'm going to just press times 2 on my calculator. And so that whole entire angle right here, meaning this whole entire arc, is 106.26 degrees. So I'm just going to write that right there, 106.26 degrees. So guess what that is going to go into? That's going to go into my x. So I'm going to put that there, 106.26 degrees over 360 times pi. R is going to be 10 minus 1/2. And then the base and the height of the triangle. So I'm going to highlight the triangle in blue, and you're going to see that this is going to be your base and your height. So this is the base, and this is the height of this triangle right here that I'm kind of highlighting in blue. I want to get rid of that. So the base is going to be 16, and the height is going to be 6, because I figured that out. Okay, so now let's go ahead and put this in our calculator. I'm going to go ahead and just estimate this to be about 106 degrees over 360 times pi times 100 minus 8 times 6, then that's 48. Okay, so I did that in my head, which you can easily put that in the calculator. Half of 16 is 8. 8 times 6 is 48. So let's simplify 106 divided by 360, which is not a pretty number. It's a 0.2944 repeating. I'm going to hit times 100 times pi and then minus the 48. So I'm going to hit times 100, which is about 29.44 pi minus 48. So this is one way to leave your answer, okay? But this is still an estimate because we ended up rounding that right there. So we probably should not stop there. We should just give the final answer in estimate form. So I'm going to hit times pi equals, so this left side is about 92.5 and then minus the 48. So I'm going to hit minus 48 in my calculator. So it's about 44.5. And this is in square feet. Okay, so it's about 40. That looks bad. Okay, of that segment. So this one was a little bit harder because now you had to throw in the right triangles to try to find the height and the base. Okay, so it depends what kind of triangle is there, but now you know how to do that if you just take the isosceles triangle and find and divide it in half that way. All right, let's do the annulus right here. The annulus is, remember, big pi r squared minus little pi r squared. So that should be pretty easy. So what is the entire radius? Well, that's 4, then this is 4. So the entire big radius is going to be 7. And then this is the small radius. So it's going to be pi 7 squared minus pi 4 squared. 7 squared is 49 pi. 16 comes from that. 4 squared Now these are like terms, so guess what? We can finally subtract the two. So what is 49? It's like saying 49x minus 16x. So what is 49 minus 16? 33 pi. So this is the exact area, 33 pi square inches. And if I want to give the estimate, then I just have to hit times pi in my calculator, and that's about 103.67. I've been rounding to 3, so I'll go one more, 673 square inches. All right, and then this last one is just kind of a review. And so we need to find the length and the width, and which is also kind of like base times height. So using algebra a little bit backwards, I'm going to show you how to put it into a box method. You're going to want to put the x squared here and the negative 18 here, and then start filling out the side lengths. Well, you know there's only one solution here. X times x is going to equal x squared. And now you want to start thinking of numbers that multiply to equal negative 18. And so we can say negative 9 times 2. And then we have to double check. We might not always be right this first time, but this is a 2x. This is a negative 9x. And you want to make sure these two blue numbers add up to equal that middle term. And it works out perfect. So I had a good guess the first time around. Negative 9 plus 2 is that negative 7. So guess what, guys? This is your length, and over here is your width. So, and they can be switched to. It doesn't matter what you put where. So this can be x plus 2, and this is x minus 9. And that is it for area of circles.